Let's talk about how to quantify work, or W. So imagine there is a system which is a cylinder and a piston. I'm going to go ahead and draw it. So there is a cylinder and a piston, and inside here there's a gas enclosed. And what we're going to do is we're going to apply a pressure on the piston to push it downwards. So let's call the pressure P. It's pushing the piston down, and then finally, so that's my initial state. And the final state is the piston moves down. So let's say the piston ends up here. So as a result of the piston moving from here, the initial state, to the final state, notice carefully what happened to the volume. The volume of the gas initially was taking up this much space, and now the volume got compressed, okay? So if I take the initial volume, so let's call that VI for initial, okay? And I subtract the final volume from it, so let's call that VF, the final volume, subtract it from it. Then the change in volume, let's call that delta V, is equal to VF minus VI. And we're going to take the absolute value of this so that we're not dealing with a negative number. And by the way, we can kind of figure out the negatives later on, but right now we're just interested in the change, okay? All right, so if we try to understand how much work was done on the system, notice carefully, the system is actually the gas inside, out here. The surroundings is everything else. So by pushing the piston down, okay, you're actually doing work on the system, okay? Excuse me. So you're doing work on the system, so the pressure is going down, so the system is actually gaining, okay? All right, so work, let's go ahead and try to define this. Work, W, is equal to, if you recall, it's force times the displacement. So F times D. Recall, we talked about this in a previous video, okay? F times D. That is force times the displacement. And so the first thing we need to understand, we need to take the force and the displacement and convert it into pressure and volume terms, okay? So force is equal to the pressure times A, the area, okay? So if I take this term out here, the force out here, the little symbol F, and replace it with P times A, then work is equal to pressure times A times D. And turns out, if you take A times D and combine them, that is equal to volume, okay? And in this particular case, that would be the change in the volume, because that the piston is moving down by a certain amount, and that amount is the distance. So if you think about this as the distance, D, that it moves, so that's the distance, okay? And then if you think about this, I'm going to use a different color out here. That's the area, okay? So distance times the area, that is going to be equal to delta V, okay? So that is equal to P times delta V. Also, you can write this as P delta V, okay? So work is equal to P delta V. Now, since work was done on the system, this is going to be a positive quantity, okay? So therefore, we don't need to put a sign out there. Now, what if the piston expanded, okay? Which means that you heated up the gas out here, and the heat caused the gas molecules to move around more rapidly, causing the piston to go up. If it expanded, then the system is doing work on the surroundings. So then, in the case of expansion of a gas, work would be equal to negative P delta V, okay? So therefore, this particular scenario would be an example of a contraction of a gas, okay? So I'll write that down here, contraction, okay? So this is kind of a simple way to represent work. Now all work is not represented in terms of pressure and volume changes, but for the major part of what we're going to learn in chemistry, pressure and the change in volume, pressure volume changes is going to dictate a lot of the work we're going to see.